Hi guys, I'm Dr.S.Nandhabalaji. Today we are discuss about the properties of matter, Young's modulus, non-uniform bending theory and experimental method. Like as the diagram shows the non-uniform bending method, these presentations expose the Young's modulus non-uniform bending method theory and uh, experimentals. Non-uniform bending occurs when a beam is subjected to a load that is not evenly distributed across its length. In such cases, the bending moment and curvature vary along the beam. The theoretical framework for this phenomenon relies on the principle of superposition, which allows the calculation of the deflection and stress due to multiple loads applied by the beam. Differential equations, the mathematical basis of non-uniform bending analysis, relies on a set of differential equations that related the bending moment, curvature, and deflection of the beam. These equations can be derived from the principles of elasticity and equilibrium. Moment of inertia, the moment of inertia, which represents the resistance of the beam to bending, plays a crucial role in determining the deflection and stress due to non-uniform bending. This properties depend on the cross-sectional shape and dimensions of the beam. Boundary conditions which specify the constraints and supports applied to the beam are essential for obtaining unique solution to the differential equations governing non-governing material conditions of the stress and strain distributions. The experimental setup and methodology. The experimental setup involves cantilever beam, which is fixed at the one end and the free end. An unknown load is applied at the free end, causing the beam to deflect. The deflection is measured at various points along the beam using precise instrument, such as dial gauges or a strain gauge. The curvature of the beam can be determined by measuring the slope of the deflection curve at the different points along the beam. Cantilever beam. A cantilever beam is fixed at one end and free at the other end, making it suitable for studying non-uniform bending. Load application. A known load is applied at the free end cantilever beam, causing it to deflect. Deflection measurement. The deflection of the beam is measured at various points along its length using a precise instrument. Measurement of deflection and curvature. The deflection of the beam is measured using a dial gauge, which is precise instrument that measures the displacement of a point of the beam. The curvature of the beam can be calculated from the deflection data. The curvature is defined as the rate of change of the slope of the deflection curve with respect to the length of beam. It represents the degree of bending experienced in by the beam. Deflection measured using a dial gauge. Curvature calculated from the deflection data. Calculations of Young's modulus non-uniform bending like as E is equal to m divided by d by 2 d square y divided by dx square. Bending moment is a measure of the internal forces acting on the beam due to applied load. The curvature of the beam is measure of its degree of bending. Moment of inertia. The moment of inertia represents the resistance of beam to bending. Young's modulus is a material provides stiffness of the material. Comparison of theoretical and experimental value. Comparing the theoretical predictions with the experimental results provides insight into the accuracy of the theoretical model and the reliability of the experimental measurement. Discrepancies between the two can be attributed to various factors such as experimental errors, material properties, and assumption made in theoretical analysis. By analyzing these discrepancies, a deeper understanding of the behavior of the beam under non-uniform bending can be achieved. Factors affecting of this material like as measurement error, material properties, and some assumption errors are the factor affecting errors. The accuracy of Young's modulus determines influenced by several factors including the precision of the measurements, the properties of the material, and the assumption made in the analysis. These factors can introduce errors in the calculated value of Young's modulus, affecting the overall accuracy of the results. Understanding these factors is crucial for minimizing their impact on the final result. Conclusion and applications of some wide range of bridges designing and building constructions, aircraft designing. These are the main applications of the non-uniform bending analysis. Thank you. Thank you, guys.